And this is a typical notice, copyright. We have seen this before, syllabus, mathematics syllabus, CSEC, 2018 to 2027. Right now, I am on section 2, consumer arithmetic, which will have 12 videos. So far, those 4 videos have been published. Also, 3 more from this section. As it relates to Objective 5, Part A on hire purchase has already been published. Part B, mortgages, is what this video will deal with. My original intention was to have that on a different site to be accessed for a fee, but on second thought, since this is such an important issue, I will also make this available on YouTube. As a matter of fact, I think I will make all videos from this section available on YouTube. From section 3, we will see how that works. A few would be available in totality, but most videos from section 3 and onwards, only part of those videos will be published on YouTube, and for the rest, you will be redirected to another site where a monthly reasonable fee is charged. So part A was already published on YouTube. Now I am at part B, and as I said, I will also make this available on YouTube, which was not my original intention, as well as all the other videos from this section. So the videos from section 1 and section 2, all such videos will be available on YouTube in their entirety, which is a slight change from my original plan. So Objective 5, as I said, it's in italics, meaning that this objective was added for this syllabus, and in the previous syllabus it was not there. Solve problems involving payments by installments. In the case of hire purchase, that was already done, and since there are no explanatory notes here, I did what I think you may need. And to make matters worse, when it comes to mortgages, that is even a little more complicated. So, as I said, CSEC did not give any explanatory notes on how in-depth we need to go into this issue of hire purchase and mortgages. So I have used my initiative and put some things there that I think you may need. No explanatory notes. So just bear that in mind. And I may actually have more than what is required by CSEC. So we already finished with hire purchase in part A of Objective 5, section 2. Now we are dealing with mortgages. Mortgages are more complex than hire purchase as they involve larger sums over a longer period of time, but basically it's the same kind of setup. Now we will consider the typical formula and its one variation normally used to calculate monthly payments in mortgages. So the one typical formula we will be looking at is this. M is equal to P, which is principal, times rate, times 1 plus R to the n power, over, open bracket, 1 plus R to the n power minus 1. Notice that this part here and this part here, they are identical, where M represents monthly payments, R is the monthly interest rate as a decimal, N is the duration in months, and P is the principal amount. Don't let this scare you. It is not as difficult as it looks. As stated in the contract, it is percentage per annum. Example, 7.5% per annum or per year. So we will need to convert that to per month and then express that percentage as a decimal. And as already pointed out here, duration of loan is in months. So if it's 25 years, we will multiply that by 12 to carry it to months. There is an alternative formula, which is P times R over 1 minus, open bracket, 1 plus R to the negative n power. Now this variation here, this one here, looks easier than the one above there. Either one can be used to calculate the monthly payments, and we will use both of them to satisfy your mind that either one will give you the same answer. Now keep in mind that you don't have to memorize these formulae for math class. You may have to do it for accounts, I don't know, but for math class you don't. However, you should be able to use these two equations if you are given the relevant data and the formula in a question. You should be able to use them. So let's begin with example 1. We will only do 2 examples. Mr. Jones wants to buy a house and plans to borrow $200,000 from a bank at an annual interest rate of 8% with a payback time of 20 years. That's all you're given. Now calculate 1 is monthly payments, 2 total payments, and 3 total interest. So this is the formula. We know what those symbols stands for, M, P, R, and N. So M is the monthly payment, that is what we want to find. P is the principal, which is 200,000. R is the monthly rate in decimal. So you divide the 8% per annum by 12 to get per month, and then divide that by 100 to carry that percentage to a decimal. N is the duration of the loan payments in months. So if it's 20 years, you multiply by 12 and you get 240. And now that we have that, we will just substitute in the equation. M is equal to P, which is 200,000, times R, which is 0.006667, times, open bracket, 1 plus R, close bracket, to the nth power, which would be 240th power. All of that divided by, open bracket, 1 plus n to the 240th power minus 1. So that m is equal to, if we work out this part on the top here, the numerator part, 1 plus 0.006667, close bracket, to the 240th power, then multiply that by this, then multiply that by that. If we do all of that, we will get 6,569.12585 over 1 plus that to the 240th power minus 1. You get this, divide this numerator by the denominator, of course, and you end up with $1,672.90. So that would be Mr. Jones' monthly payment. You need a calculator, something like this. This is a typical calculator that is allowed for CSEC. Particularly, we want to look at some of these features. There is an exponent here, which means times 10 to. There's an open bracket here and a closed bracket here. There's sine, cosine, tangent, and if you hit shift and you press this sign, you are going to get inverse sign, which is the one below there. There is a square root here. There is a square here. There is a cube here. So for example, if you want to get 4 squared, you press 4 here, and then you press square there, and then equal, and you get 16. That's 4 squared. Clear? If you want 3 cubed, that's 3. This x cubed here is 3 cubed, equal sign, and you get 27. So you can easily get any number to the second power and any number to the third power. What if you want a number to the fourth, fifth, or sixth power? Then you use this button here that looks like an upside down V. So let's clear all of that. Say you want 3 to the fourth power. Now, if it were square, you'd press that. If it were cube, you press that. But if it is 4, you don't have any shortcut for that. You press this upside down V, and then you press the power, let us say 4. So it looks like that. That means 3 to the 4th power, that is 3 3s, 9 3s, 27 3s. And you press equal sign, and you get 81. So this becomes very important, especially when you want to express something to the 240th power. So keep that in mind. As we actually look at this example 1, we will begin with open bracket 1 plus 0.006667. We will then close the bracket, but we want that to the 240th power. So we press this button here, 240th power, and we press equal. So that part there works out to this number here, this number here. We will then multiply that by 0.006667, and then we will multiply that by 200,000. That's 200,000, and we press equal sign, and we get 6569.1554. The calculation I have on the PowerPoint is slightly different, but it wouldn't make much of a difference. So we write that down as a numerator, and then we clear that, and let's do the below piece, which is open bracket 1 plus 0.006667, close bracket, to the 240th power, and we can work that out by pressing equal, and then subtract 1 from that, minus 1, and we get 3.9268,480. You get, so that is the answer you get when you work out the below part. So now all we have to do is divide the numerator by the denominator. So I clear this, and I'm going to enter the numbers I have here on the PowerPoint. 6,569 .12585 divide by 3.92680. 3.92680 equal, and we get $1,672.89. That's for using the force formula to find monthly payment. Now we can get that same answer by doing the first line, the whole of the first line, without writing down anything for that middle line. So let me show you how that is done. You will have to use an extra pair of brackets in the denominator. So I start with open bracket 1 plus 0.00666667 close bracket to the power of 240. I get this, multiply that by 0.006667, then multiply that by 200,000, equal that. That is what I get at the top. Now, without writing that and doing the second part separately, I can do the division and the second part all in one step. So I do division. So everything at the top will be divided by, and I open bracket here. That's an extra open bracket. And now I use this open bracket that I see here. Open bracket again. 1 plus 0.006667, close that bracket to the power of 240, then I minus 1, and I finally close that bracket, and I get 1,672 and 88, which is the same answer we got before, except this time we eliminated the second line. Either way, you will still get the same answer. That is using the force formula. All right, so we worked it out. This is what we got from the last slide. Next part of the question say, find his total payments. This is very easy. If you know the monthly payments and you know that he's paying for 240 months, you just multiply the monthly payment by 240. And so over the 20 years, he would have paid $401,496. That's his total payments. Next part of the question says, find the total interest. Well, listen. If he borrowed 200,000 and he ended up paying 401,000 plus, then his interest will be all that he paid minus what he borrowed. So his total interest will be total payments minus the principal, which will be, that's total payments minus the principal. And so he ended up paying $201,496 in interest over the 20 years, which is a little more than the principal that he borrowed. Now let's try this formula down here to see if we will get the same answer. When we use that formula, we got $1,672.90. Now let's use this formula and see if we will get that same number. So M is equal to 200,000 as the principal, multiply by the rate, which is this, over 1 minus, open bracket, 1 plus the rate, close bracket, to the negative 240th power, Work out the top part here. You get this divided by the below part. Well, it is this 1 minus this part here, which gives us this. So when you subtract this from 1 and you use that to divide $1,333 and so on, you ended up with $1,672.88. Now you may say, well, this one had 90 cents. How come this one says 88 cents? That's because of our rounding off of this number here. 0.006666 or 66667. So you will have a slight variation. That is nothing to worry about, especially if Mr. Jones is paying this amount of money over a 20-year period. A few cents would not make much of a difference. Now let's use the second formula. Clear? 200,000 multiplied by 0.006667 equal, and we get 1,333.34. That's what is written down there. And then we do the below line, in bracket, open bracket, 1 plus 0.006667 close bracket, power, negative 240. That negative is not this minus sign here. That is this button here. On some calculators, you will see that button as a plus slash minus. So this negative, so it's negative 240 equal to, and so we get 0.202969, which is what we have there. We will then subtract that from 1. So clear, 1 minus 0.202971, and we get this. Now we will divide the 1,333 by that. Now you can write it down and then divide, but what I will do, instead of writing it down, I will just divide that by the 1,333 and then I will inverse it rather than write it down. So I'm going to divide by 1,333.3334. I get this, but that is not what I want. What I want is the inverse of that. And so I press this inverse here, and I get 1,672.87.88. Now I can, of course, do all of that in one step without writing down anything. Clear? But I will need an extra pair of brackets down here in the denominator. So let's do all of that one step without writing down anything. 200,000 multiplied by 0.006667 equal to, that's the answer on the top, divide by open bracket 1 minus another open bracket 1 plus 0.006667 close bracket to the power of negative 240 close bracket, and all of that I will get the same 1,672.88. So you could do it in one step if you're comfortable with that, or you do the top part, then do the below part, and then divide the numerator by the denominator. So that was for example 1. Now, other questions that may be asked: how much of the first payment was interest? And after the first payment, how much money did he still owe the bank? So let's deal with the fourth question there. How much of the first payment was interest? Well, remember, this is the amount of money that he borrowed. He is paying 8% annually. Divide that by 12, we will get his rate for the month. Divide that by 100 to carry it to a decimal. And so we find that out of this $1,672.90, $1,333.33 would be interest. So really, he isn't paying much towards his loan at the beginning of this arrangement. Now, after the first payment, how much money does he owe the bank? So the balance after the first payment will be the principal minus the monthly payment minus the interest. So you take the monthly payment minus the interest, which gives us $339.57. That is the amount that goes towards paying this loan. So at the end of the first month, his loan decreased by only that amount. And so it is still $199,660.43. It will take a long time to pay off that loan, as we said, 20 years. Now, Microsoft Excel, and you don't need to know this for math, but if you're doing IT, maybe you need to know this. If you borrow $80,000 to buy a car at 10% to pay off in 5 years, that's all you need to do. This 60 will automatically be calculated based on the formula in the sheet. This payment will automatically be calculated, and that one and that one. That is the one for a car. Same thing for the house. If you borrow $200,000 for 20 years, paying 8%, all you need would be those 3 pieces of data. This 240 will be automatically calculated based on the formula in the sheet, not the formula that we were using just now to calculate monthly payments. And then this monthly payment will be calculated, total cost will be calculated, and total interest will be calculated. If you are interested in seeing what formulae were used, so to get this spreadsheet looking like this, this is the formula that was used. All you need were those 3 pieces of data, and everything else here, a formula in that cell was used. The same thing for the house. Interest rate, number of years, principal, that was calculated based on this formula, payment on this formula, total cost on that formula, and total interest on this formula. Now remember, this is not required for CSEC math. Maybe you have to do something like that for IT. Now that we can calculate the monthly payment, I need to introduce you to something called the amortization schedule. As I said, I don't know if CXC requires this. They didn't say, but I will introduce you to it. You may find use for it now, especially if your parents are about to take a loan to build a house, or since there may be young adults who are looking at this video and thinking of taking a loan, this amortization schedule will become very useful and informative. So I will introduce you to it. Whether you need it for CXC or not is not so much the question. You may need it in real life. So what is an amortization schedule? It's a list of all payments you are required to make on a loan, showing monthly payments, interest, and balance. So unlike that previous spreadsheet I was showing you, this one shows the beginning of the amortization schedule. Again, all you need to enter would be the amount of the loan, annual percent, and the number of years. Once you do that, the formula that I have entered in this spreadsheet will calculate the monthly rate, number of months, the monthly payment, and then it will also tell you that from your first payment that you pay this amount, $1,333.33 went to paying interest, $339.55 went to paying towards the principal, and so the principal has decreased by this amount. So if you subtract this from that, you will get this, and so on. So the next calculation, you're still paying this amount, monthly payment, but now notice your interest drops a little because now the interest is calculated from this amount, not the 200,000, and so on. So this is the first part of an amortization schedule. Here we are down to halfway, 120th payment, that is half of the time, but notice you are not yet halfway paying the loan. The loan is still 137,881. Remember, the loan was 200,000. So halfway into payment, you are not yet halfway paying the loan. As a matter of fact, until you reach these payments here, then the interest will be the same as what you're paying to the loan, but you're not halfway paying the loan yet. However, at this point, after here going down, more of your money goes towards paying the loan than towards interest. So if we skip some of those sheets and we go along to the last payment, 240th month, you pay this. At this point, the interest is only $11.08 because at this point you only owe the bank $1,661 and some cents. And therefore, most of your money goes towards paying the loan. So if you are interested in that Excel spreadsheet that I just used there, you can access it at the link shown below. You can copy and paste the link into your browser. Now, of course, this is video, so it's no sense for you to copy that. To see the formula in Microsoft Excel, hold Control and then press the tilde key together. Do the same to get back from your data sheet. So Control and this one. You will see all the formulae in your Excel spreadsheet. And as I said, if you access the spreadsheet online or you download it, you can see all the formulae that I have put in place. And maybe you could put it to some good use. I am using an older version of Microsoft Excel for those who still have the old version. For those of you who have the newer version, it will be easy to follow what I am doing. So let's deal with the one with the car. If it's 10% annual for 5 years and you borrowed $80,000 to buy that car, this 60 here is based on a formula that is in here, which is really 5 multiplied by 12. The monthly payments also based on a formula, the total cost, and so on. Now, in the case of a house, over here, 8%, 20 years, which was converted to 240 months, $200,000. All of these, almost everything here, were calculated by a formula. Now, to get the formula, or to see the formula, you hold Control down and the tilde key, and these are the formulae that were used in this spreadsheet. Now remember, this is not the two formulae we use to calculate monthly payments. These are formulae in Microsoft Excel. So all we needed was the annual rate, the number of years, and the loan amount. This is calculated by that formula. This is calculated by that formula, monthly payment, and so on. That this is also included in a spreadsheet online. Control and tilde to get back here. This just gives you the summary, the overall picture. Now, if we want the details, as in the case of the house, go to amortization schedule. This is what it looks like. Loan amount, interest rate, and years. Those are the only three pieces of data you need. Everything else here is done by a formula. If you want to see the formula, press hold Control and then press that tilde key there, and you will see all the formulae. So here are the formulae. All we need to enter were these three pieces of data here. Everything else will be calculated. Monthly payment, number of months, monthly rate, present value, payment, first payment, interest from that, how much of that first payment goes towards the principal, and how much of the principal still remains. We could go down this list right down to 240. Down here has the sum of payments that you made, the sum of interest that you made. And we will look at that in a little while. So let me get back to the datasheet view. Control and tilde. Now, when this happens, it means that there is not enough space to show the data there. So I will open it back a little. Okay. So I am saying that if you see an amortization schedule, you should be able to understand what it says. And you may be able to use it to help your parents pay off the loan faster by pointing out that in this first payment here, if they add this second 341.81, that they would have paid off 2 payments and saved this amount in interest. Of course, if they could make 2 payments more, so if they paid a 1672.88 and then this amount more here, then they would have in effect paid 3 payments, and so their next payment would be payment 4, and they would have saved this amount of interest over those 3 payments. So if you're a young adult and you're thinking of taking a mortgage, you could look into that. If you're a student in school and your parents are thinking of taking a loan to build a house, for example, then you may be able to advise them how to go about this. So let's just change this 8 to 9 and see what happens. If I press enter, you will notice straight off that some things will change. This will change, for example, that will change, for example, and all of these numbers here will change. So I will now press enter. So now your monthly rate increases, so you have to pay more payment per month. And out of the first payment, $1,500 goes towards interest. A little less than $300 goes towards paying the principal. So at the end of paying almost $1,800 for the first month, your loan decreased by about $300, and so on. Of course, we can change this 20 to 25. If you have a longer period of time to pay the loan, even at a high interest, then your payments, monthly payment, will decrease. 9% over 25 years, $1,678. Of course, now you are paying for 25 years. As I said, you can actually get to use this spreadsheet on the link that is given in the description. You could download it or you could use it online. Example 2, Mrs. Thomas wants to buy a boat and plans to borrow $340,000 from a bank at an annual rate of interest of 9% with a payback time of 15 years. So calculate her monthly payments or total payments and the total interest. So let's use that formula we were using for the last example. M is equal to P times R, open bracket, 1 plus R, close bracket to the nth power, over, open bracket, 1 plus R, close bracket to the nth power, minus 1. As I said, that formula may look difficult until you realize that that part and this part, they are the same. So it's fairly easy to remember and use, but remember what I said, you don't have to memorize that for this class. We want to find monthly payments. Principal is $340,000. Rate is 9% per year. Divide that by 12 to get per month. That is still percent. Divide by 100 to get it to decimal. 15 years by 12 months, 180 payments. So we just substitute the numbers we are given. 340,000, that is P, times R, which is this, multiplied by open bracket 1 plus R to the 180th power over open bracket 1 plus R to the 180th power minus 1. You work this top part out first. So you add 1 to 0.0075, find the 180th power, and I will show you how to do that on a calculator in this same video. Multiply that by 0.0075 and then multiply that by 340,000. You work out that top part, you get this. The below part, so you add 1 to 0.0075, and then you find the 180th power, then you minus 1 from that, and you get this. Divide the numerator by the denominator, and you get $3,448.51. Now in example 2, I am not going to do it the long way. I'm just going to do it the short way. So example 2, first method is open bracket 1 plus 0.0075 close bracket to the 180th power equal to, then I will multiply that by 0.0075 and then multiply that by 340,000, that will be the top part, divide by, now I am going to have two open brackets, open bracket, and then open bracket again, 1 plus 0.0075 close bracket power 180, and then I'm going to minus 1 from that and close bracket again, and I get 3,448.51. That is doing it the first method. Let's do that using the other formula. $340,000, that's P, multiplied by R, 0.0075 over 1, minus open bracket 1 plus R, 0.0075 close bracket. Now note this minus here. To the negative 180th power. This top part here works out to be that, and the below part works out to be this, and I will show you how to do that on a calculator. Divide the numerator by the denominator and you get $3,448.50. Never mind that over here we got 51 cents. As I said, when you're dealing with large amounts of money over a long period of time, a few cents do not make much of a difference. So that is close enough. Let's do that same thing, the second method. 340,000 multiplied by 0.0075 equal to that, divide by open bracket 1 minus another open bracket 1 plus 0.0075 close bracket, and we want what is in that bracket to the negative 180 power, so that's the power negative 180, and then we close the bracket and we get 3,448.51. So we calculated our monthly payments, which was this. We need to know her total payments. This is very easy. If she is paying that amount of money per month for this amount of month, just multiply the two things. $3,448.51 multiplied by 180 months, and that is her total payments over the 15 years. Her total interest, again, this is very easy. If she paid this amount of money and she borrowed that amount of money, you just subtract the principal from total payment, and you would find out that she actually paid $280,731.80 in interest. As I said, other questions that may be asked: how much of the first payment was interest? And after the first payment, how much money did she still owe the bank? So let's deal with this. How much of the first payment was interest? Well, she borrowed $340,000, 9% annually. Divide by 12, you will get the percentage by the month. Divide by 100, you will get the decimal. So once you do that, the interest from the first payment is $2,550. Now, after the first payment, how much money did she still owe the bank? So you take the principal, and from that, you will subtract the first payment minus the interest. When you do that, you get $339,101.49. This is the amount that you still owe the bank after the first payment. So here is the amortization schedule. 340,000, 9%, 15 years. First payment is this. That amount goes towards interest. This goes towards principal. So when you subtract this from that, you get $339,101.49. That's at the end of the first month, and so on. So in this part of the video, you learn how to use this negative here and this power, that is square, that is cube, those are predetermined, and this is any more power that you need, like 4, 5, 6, 7, 8. Conversely, if you want to find a root, now if you want to find square root, that is there. If you want to find cube root, that is below there. If you want to find fourth root, then you would use that function below there, and to get that function, you will have to access Shift and this same button to get that one down there. Okay, so hope that helps. So solve problems involving payments by installments, as in the case of hire purchase, previous video. and this video, mortgages. And that brings us to the end of this video, which is part B of video 5 based on objective 5 in section 2.